Okay, I think we can get started. Share the screen. Can you guys see my screen?
Yeah.
Okay, so today our session is on maintenance of traffic, how we design it, what are the components of maintenance of traffic, what that we need to look into while designing the traffic control plans. So today's session mainly involves top two bullets. What is MOT? What MOT standards that we need to follow. The remaining three bullets will be discussed in the next sessions. Um, so what is MOT? So MOT is basically it's a planning and implementation strategy to maintain the traffic and also safely through a work zone incident or at the same time providing safety for those working on the roadway and also for the people driving on the roadway. The goal of the MOT is to minimize the disruption to the traffic, prevent accidents, maintain accessibility while work is being performed on the roadway. Another legal aspect of MOT is reducing the exposure to litigation for the agency that is doing the work. How do we make the work zone safe? So basically, what we need to do is we need to provide a good design as engineers and also follow the state standards and guidelines. We need to do more than the minimum in terms of the design. So if the minimum standards are, let's say, providing 10-foot lanes or 11-foot lanes, we should try to maximize by providing a safe movement of traffic and also safety of the workers present in the work zone. We also need to provide better communication with the road users. That's how they know what needs to be done, what lies ahead in the roadway. We need to provide better signs. We need to provide better channelization devices, tapers, and all those stuff, so that we can have them traverse through the work zone safely and provide safety for everyone involved. We also need to train all the workers, not only the engineers who are designing, but during the construction, the contractor or whoever is working on the work zone, they all need to be trained what needs to be done in terms of MOT. So these are the commonly known acronyms in the MOT. MOT is maintenance of traffic. I believe everybody knows about that. Temporary traffic control. These are um, different terms that are used. These are pretty much same. In terms of somebody says MOT, you can assume that MOT is maintenance of traffic. But if somebody says temporary traffic control, TTCA, those are the basic standards that are shown in the category 100 of the MDSHA book of standards. It's the same thing. TCP, traffic control plan, is pretty much same thing. Who's responsible for doing the MOT design? Usually at the BAI, highway design team is mostly does the MOT design, but it depends on who is leading the project. Basically, sometimes structures might be leading the project. In our case, even structures projects, all of us highway design will do the MOT design, but it depends on who is involved in the project. If no highway is involved, only traffic and structures involved, our traffic department can do the MOT as well, MOT design, without the involvement of highway design people. So various standards for maintenance of traffic. So there are national, federal standards, and also there are local state standards. So basically, the national standards are set by the Manual on Uniform Traffic Control Devices. This is called MUTCD, which is developed by Federal Highway Administration. So the latest version of MUTCD is 2023 version. State hasn't, as far as I know, Maryland State hasn't adopted the 2023 version yet. We are still utilizing 2011, basically 29. The last version of Federal Highway MUTCD was 2009. And the SHA has took the 2009 version and added its revision to the 2009 and issued the 2011 version of Maryland MUTCD, which we basically utilize for all the traffic design, for the signs, signing, marking, MOT, pretty much everything. Another standard, that federal standard that we use is AASHTO Green Book. There's not a whole lot in terms of AASHTO Green Book involvement, but there are some aspects of the highway design that are implemented in the maintenance of traffic design, which may be like side distances, shifting tapers, and speed limits, and all those stuff. Those basically come from AASHTO Green Book. So if you guys have any questions while I discuss these stuff, you can just stop me and we can discuss while we are on the sheet, on the slide that we are presenting. So as I said, the primary source of MUTCD, MOT standards is MUTCD, which is the federal. And as I said, the state implemented our own, MDSHA implemented their own revisions to that MUTCD, which was implemented in 2011. So basically the 2023, there is a code of regulation, for code of federal regulation 23, I believe, based on the United States code that requires that USDOT, which is Federal Highway Administration, shall promote Manual of Uniform Traffic Control Devices on all roadways that are open to the public travel. So basically, MUTCD has 9 parts. The latest version of the MUTCD has 9 parts. Parts, I believe, parts 6 through 9 are related to traffic control. They divided traffic control for pedestrians, traffic control for vehicles, and all other into different categories and put it into last 6 to 9 parts. The state supplements. So as I explained it to you, the state has MUTCD supplement. In addition to the MUTCD supplement, you can see that in the picture right here on the right, extreme right. That's the state supplement that we use. In addition to the MUTCD state supplement, we use the Book of Standards, category 100. Basically, all the TTCA, TTCTA standards come from Book of Standards, category 100. In addition to that, we also take the accessibility policy guidelines for ADA and bicycle facilities, because ADA was not that big back in 2003-4, but with the complete state policy implementation of pretty much all agencies, all modes of transportation, including pedestrians, bicycles, all needs to be looked at while designing the MOT. Basically, if you have a sidewalk, if you have a work that is impeding the sidewalk, you have to provide alternative access routes for pedestrians and all other travel modes. Not only the roadway travel, but also all other modes of travel. That's why we also have to follow these guidelines while doing the MOT design. as I said, METCD has latest version that is 2023 from Federal Highway, but 2011 we use that for our design. So basically what SHA does is, we usually take, SHA is allowed to take the federal METCD and they implement their standards. So on the left that you see here this is the 2011 version of METCD, and this is the 2009 version of Federal Highway METCD on the right side. So pretty much both of them are same. If you look at the guidance number 12 on the top of the page, guidance number 13, pretty much all language is same, but our state is allowed to implement our standards, which state highlights it in a different text. So those are the blue text that you see on the left is the state implemented standard. So basically, we have to follow those standards as long as we are designing any roadway or any facility within the state of Maryland. And this usually SHA or OOTS, they make the revisions and then they submit it to Federal Highway for their approval. Once they approve these revisions to the standards, SHA issues these revisions to all the consultants or whoever is working on the state projects. So METCD has 4 levels of compliance. Those are shall, should, may, and support. Basically, shall is a standard which has to be followed. Should is a guideline, and the may condition is an optional condition. Support is we need provide additional information for support. So these other conditions, when we have METCD trainings, we should be discussing these more in detail because this requires in-depth discussion because this is not METCD training. I just put 4 of these conditions and just for the brief discussion. So the fundamental principles of maintenance of traffic, there are 7 of them. Safety, traffic hindrance, positive guidance, inspections, road safety, training, and public relations. So basically, the safety of everyone should be an integral part and a priority element for every project. We should also consider all road users, as I explained it to you in previous slides. While designing the MOT, we should consider all roadway users, not only the roadway, but also the pedestrian and bicyclists. So the traffic hindrance, we should try to minimize the hindrance. So basically, as little as practicable, we should reduce as much as possible. We should reduce the hindrance to traffic. We should consider avoiding congestion and also avoid lowering the speed limits as much as possible. If the work activities can be scheduled during the off-peak hours or nighttime, if possible, if it's not a residential area, those options should be looked at first because those would provide more work can be done with less hindrance to traffic and also less more safety for the road users during nighttime and off-peak hours. So as the traffic is more, the possibility of having crashes and also congestion is going to be more. Reducing the speed limit, as I said, should be the last resort, and it should be based on the engineering study and judgment, and it should be approved by the district engineer, basically. Usually the reduction in the speed limit is 5 miles an hour or less, but sometimes it can be 10 miles per hour, depending on the conditions of the roadway and depending on the engineering judgment, and as I said, depending on the district's approval. Whenever if let's say if we reduce the speed limit in a work zone, and the work zone is not active, but still the reduced speed limit sign is there, the sign should be covered all the time when there is no active work zone. We cannot keep the work zone not active and keep the sign active. So it has to conform to whatever the traffic conditions are prevailed at that time. So at that time, what we have to do is cover the reduced speed limit sign and uncover the regular speed limit sign, and then let the traffic pass through using the regular speed limit sign. So also the third one is positive guidance. We should use the standard devices and provide reliable information, and whenever the design is done. Using the flagger should be the last resort unless if it's a single roadway and there is no other alternative, and then you can go with flagger operation. And those flaggers are also can be implemented during the non-peak hours, and during the peak hours we will try to reduce the use of the flagger as much as possible. Road safety. So yeah, during the day and night, we should be doing the inspections as much as possible. If there are any signs or any channelization devices that are damaged, like the drums, reflectorization has reduced on some of the drums. Sometimes the contractor, what he does is he reuses the drums. Some of those drums might not have proper reflectorization. Those cannot be, when you do the when you do the maintenance traffic inspection, those should be removed and replaced with the new ones. Training, as each person who's involved in the design and also during the work, if he's present during the work in the work area, those people have to be trained. It doesn't matter if it's a person who's in the upper level management who makes the decision, and or the field engineer, field personnel, or designer. All of them have to be trained in the MOT. And public relations, maintaining good public relations should be another aspect that we need to look into always. If you are working in a work zone, it's in terms of construction work, there may be situations where you might encounter a driver who might be, upset with the traffic conditions. You have to be courteous as far as the person who is working in the field. They have to be courteous, and they have to be, maintaining good relationship with the public. The key components of the MOT are the traffic control plans. So basically, detailed plans outlining the temporary traffic control patterns, detour routes, and control measures. Those will be discussed in the traffic control plans. Temporary traffic control devices. These might be signs, cones, barriers, temporary signals. In some situations, we might not find temporary signals for all this whole lot, but there may be situations where you may have to use temporary signals. Pavement markings used to guide the traffic safely, and also work zone measures. So the protection measures for the workers and road users, like including the buffer zones, and the flaggers and temporary barriers, concrete barriers. These are the work zone measures that we have to implement for every traffic control plan. Public communications. So basically, these are notifying the public about the lane closures, for providing PVMS signs, and also detour signs, and notifying the public about the expected delays. These are the communication strategies that has to be maintained for the MOT. The regulatory compliances, those are basically following the standards manual of uniform control devices and TTCAs and SHA, and other policy SHA guidelines for shown in the temporary traffic controls and other policies that we have to follow. The components of traffic control zones, basically, There are four components in the traffic control zones. There's a advanced warning signs, which is the area that you can see here. These are the advanced warning signs area. This area basically tells the traffic that what he has to expect to pass through this work area. And then there is a transition area, which is the second area that you can see on the screen on the right. So this area moves the traffic from its normal path and away from the work zone into adjacent lanes. So that it protects the workers and also the drivers from the work area. The third area is the activity area, which includes buffer space and workspace. So buffer space is very important while designing the work area that you can see. So it's right before the work area. I'll explain these to you later in the next slides, but sometimes we may not have enough buffer area. So sometimes it is allowed to use 100 feet minimum buffer if you absolutely do not have any area that you can provide for buffer, but you do have to provide minimum 100 feet buffer in certain conditions. It depends on the reviewer. Sometimes they may ask you to change the complete design if you do not have buffer area, but 100 feet minimum of buffer area needs to be provided. This buffer area should not have any vehicles or anything. It should be completely clear of any obstructions. It's completely free of any storage material, any construction equipment. This area has to be completely clean. And then the second part of the activity area is the workspace. This is basically the work area, workers and equipments, and all of this area is stored in here. That's the second part of the activity area that's there. And the last area that you see on the screen is the termination area. That's right after the termination, right after the work area. It's the termination area. Sometimes you can provide buffer space. That you can see here, you can provide the buffer space and also the termination taper. Oftentimes you would not have enough buffer space, but if you do have space, we should provide longitudinal buffer space past the work area. And the termination taper, usually this termination taper is when I do the design, I assume a termination taper of 100 feet for each closed lane. So if you close one lane, you had to provide 100 feet of termination taper. If you close two lanes, you provide 200 feet termination taper. So on. If you provide 3 or 4, you increase by 100 feet every lane that you close. We will discuss more in detail of these work areas next. So the first area that I showed you in the previous slide was the advanced warning signs area. So if you can see on the screen on the right, so this area tells the traffic what to expect ahead, basically. This area may start well ahead of the work area, maybe approximately 1 mile or less. Sometimes if you have 40 miles or less low-speed roadways, the signs may go up to half a mile. If you have high-speed roadways, the signs might go up to 1 mile. This area also includes area of the shoulder taper, which you can see here. This is the shoulder taper right here, and advanced signs. So basically this entire area from this point all the way until here, this is the area of advanced warning signs. So basically the area, this area, the main aim of this area is to get the driver's attention and tell them what's going on the roadway, and also tell them what they need to do to traverse through this work area. So the second aspect of the work zone is the transition area that you can see on the circle area. That's the transition area. Basically, we are closing a lane in this case and transitioning merging one lane to create only one lane operation, one lane through the work zone. So this area is where gradual transition from one condition to another condition occurs. So basically, in this case, from 2 lanes to 1 lane. And And also, this requires basically lane closure. So basically, you have to have a lane closure arrow, shoulder tapers, shoulder taper drums. Usually, shoulder tapers are 7 drums. Usually, they put it in. Then the next area, transition. So how do we do these transitions? There is a formula that we use for any tapers when we design it. So if the lane is 11 foot wide, your taper is the width that you see in the formula, that the term W stands for the width of the roadway. If the lane width is 12 feet, and if you're designing a 40 miles an hour road, 12 feet lane closure, you need to provide at least 320 feet taper if the speed is less than 40 miles an hour. If the speed is high speed, then you have to provide accordingly. If it's more than 45 miles an hour, then you have to provide 540. Basically, from the table, you can see that any speed that's lower than 40 miles or less than that is considered as low speed. Any speed on the roadway, when I say the speed is prevailing speed. If you can see it in the formula here, basically when we design it, I know we designed for the prevailing speed, whichever is higher, basically. The prevailing speed or the posted speed. Most of the time, the prevailing speed is higher, but sometimes it can be less. So basically, you have to determine which speed you are designing for. The tapers, there are different types of tapers. I believe I had to have included another. So the merging taper, shifting taper, shoulder taper. Let's go to the next one. Okay. So the merging taper, shifting taper, and the shoulder taper are explained it in here. So basically, if you're closing a shoulder, this is where you put the arrow panel to close the travel lane, and that's where the shoulder taper ends. On the right slide, in the same slide, on the right picture that you see, that 1/3 of L. Okay. The L basically, L is, if you go back to the previous slide, L is where the speed is, when the speed is greater than 40 miles an hour, that you have to calculate based on the width of the roadway and the prevailing speed. So you get the value of L, and that L, based on that L, 1/3 of L, you close the shoulder. So if you get a L value of 500 or maybe 450, and then your shoulder taper should be 150 feet as such. So the second taper is the merging taper. So if you're closing a lane, you cannot just immediately close the lane. You have to give advance warning, and also you have to give advance merging distance for the vehicles to merge into an adjacent lane. That's what the merging taper is. The merging taper, if you go back to the previous slide, so the merging taper is given here. This is the same L, but on the expressways, 1,000 feet minimum should be maintained. And then the shifting taper. The right slide does not have a shifting taper, but the left picture has the shifting taper. I had to put the different picture here because the right one did not have shifting. So shifting taper, here we have 2 lanes coming in, and the work is on the left lane. So we had to shift the traffic into the shoulder. That's where the shifting taper is. So basically you are shifting, you're not merging any lane here, but you are basically taking the same width of same number of lanes, same width, and moving over into the shoulder area. And that's where the shifting taper is. So basically all of these can be found in the SHA category code 100, the MD standard 10408, 10408. This should be 08, not 80. I think I put it wrong here. This should be 08. So if you go to that standard, you will see all these standards. The third area, yeah.
Pushkar has his hand out. I think he has a question.
Yes, Pushkar. You're muted. We still cannot hear you.
I just want to take a moment here, and pause sort of the discussion here a little bit. I'm just curious to know how many of the attendees are currently or in the recent past have worked on temporary traffic control plans, developing the design of it, preparing drafting. Can you do a show of hands? Okay. Okay. All right. So I see 6 people here said. I see a lot of water resources folks. When you guys are working on a project that is managed by you, a drainage improvement project or stormwater management, whether or not it's adjacent to the roadway, a lot of the times you would still need some sort of a traffic control plan. And whether it's a standard that you're going to use and you don't need to develop like a separate plan sheets and you just need to refer to the standards, but you do need to know what standards to use and understand how the MOT works. How about anybody from structures? I don't see anybody from
We're on
structures.
here. There's a couple of us on here.
Okay.
So, Henri and Mark are out in the field right now. We use standards, standard MOT setups only to the extent that it's required by for inspection work that we're doing. For instance, we have to apply for lane closures with VDOT right now because we're doing inspections for VDOT. So, but they have standards that are already established that we use those and only those. So we don't really have to go through a lot of design. We just have to look at what's, do we need to take a shoulder? Do we need to take a lane? Do we need a short-term closure or long-term closure? But nothing that stays in place more than a few hours.
Right.
Yeah.
So for Chang is here, Miat is here. I don't see Adam here, but for traffic people, when you are going out in the field and you're collecting traffic counts, or you are doing any field studies, it might apply to you as well, where you may need to request if you're working alongside a high-speed roadway, which in SHA's definition, anything posted speed limit of 45 or above, you may need to have a crash cushion or truck-mounted attenuator to follow you as you are in the field. So if you are working within the clear zone, if you know what that means, it's within usually 15 to 20 feet of the edge of the shoulder. On a roadway, you are doing work, whether you are looking into an outfall structure or you are doing, there is a clear guidelines from SHA that you need to follow their standard for worker safety requirements. The other thing I want to quickly also mention, Shaik, I don't know if you covered, I joined a little bit later, but as you are working on a project and sort of, you know the sequence of construction that you want to follow, there is some considerations there as far as flexibility to be achieved there as well. But there is, just like anything else, there is a planning component of developing a work zone plan. So determining, how long the project is going to be, like length, physical length in miles, what type of construction you're going to have, whether it's going to be nighttime, and not just construction as a whole, but individual operations within that construction, because some operations, for example, setting up the temporary concrete barriers, could be, a mobile operation where they're setting up the barriers from a truck. Or there could be some operations that may take 15 minutes to 1 or 2 hours. And then more than a certain number of hours, and then daytime versus nighttime. So if you look at the SHA standards or even VDOT standards, you will see the work zones are defined by the speed, the type of roadway, and the type of construction. And that's how the develop contents. If you go through them, you will see that the standards are assembled in that order. And then when you go into individual standards, a lot of it, which Shag is going through, you have to really read very carefully every single thing that is on that standard, where it applies, the terms and conditions, that where it applies, signage, marking, tapers, all those things that Shag is going over. That comes sort of after you have gone through that planning stage and figuring out what is the type of work zone, what are we trying to, how are you trying to sign and mark and design the work zone so that your worker safety is always your number one priority, but safety of the traveling public is also a high priority. And then comes mobility and other things. So if, for example, that 695 crash, right, we all aware of, has been a couple years almost. They had a concrete barrier on the left side, and the workers were behind the barrier, and still a vehicle was able to encroach into the into the work zone and strike those workers. And then a lot of thoughts there that came out after that crash happened, after investigation, was whether or not it would have made sense to have a another additional lane closure during the off-peak hours of travel when the traffic is slow, and also reduced speed limit. And if you go through that work zone now, you will see that's what they are implementing.
Yeah.
I went through that this morning and I saw they had a variable speed limit of 45 miles per hour through the work zone.
Yeah.
On a posted speed limit of 55 miles per hour. And they had an additional lane closure adjacent to the concrete barrier. So some of those things are discussed at a very early stage, needs to be discussed at an early stage with the client, the district traffic, if you're working with SHA. And they will give you guidance. And there is a separate process called Transportation Management Plan. This training, I'm not sure if we are going to dig into that, but that's basically the Transportation Management Plan is a document, a report that is prepared by a consultant to do that planning, like really looking into various aspects of the work zone and figure out what's the best way to manage the traffic during construction. And I will leave it at that. I just wanted to, provide this.
Push cards. Ron's on here too.
Yeah.
And I just wanted to echo, so give you guys a little construction perspective. I know we have a training coming up, but I wanted to listen in to see a little bit, but I want to talk about just real briefly, and I'm sorry for hijacking anything, but talking about the planning phase, and you talking about the clear space and the buffer zones and all that, and that's all great. But one of the things that you got to communicate with the district, and as you're looking at construction phasing, is once we have MOT implemented and we're out there and we're working and everything's going according to plan, we also have to take into consideration deliveries and stuff that's coming to the job site. Those things need to be discussed at the planning stage on what types of materials are coming, and asking those questions while you're developing the design. Because what you don't want to have happen is have an MOT plan that's perfect for the commuting public and the worker safety, but we can't get any deliveries in construction. And then you got a modified MOT plan in the middle of a perfectly done MOT plan. So that communication is important to what Pushkar was just discussing, is getting the buy-in from construction, and even doing, in the planning stage, not a formal constructability review of what you're doing, but a formal discussion on how do they see it's going to be implemented. And they can give you some guidance and some ideas, and maybe it's as simple as making the buffer zone at the beginning 50 feet longer so we can get deliveries in. Something that simple can solve a whole lot of work later on than when barrier wall is already up.
Yeah, and also one more thing is, Aaron, I think you mentioned previously also, access to the work area, access point. So where the access point is going to be looked into first. We need to, as I said, the deliveries, they have to have an access point to deliver the project, and also the workers needs to every day, they need to get into the work area. Where is the access point? That has to be clearly defined on the plan as well.
And unfortunately, that's what Pushkar was discussing on the 695. The incident happened at an access area.
Yeah.
You know, it wasn't thought about what happens when we're not using the access area during the day. And that's the conversation at the end of the day, what something that small of a conversation, what it could lead to in a work zone. Work zone was set up fine. You know, there was no issues with the workers were protected, but the access area is what was breached.
And also one more thing I want to bring in is as Mike was mentioning, most of his work is just inspection and stuff. So there are MOT has standards. So there for long-term work and short-term work. If you look into category code 100 books, any work that is done 12 hours or less, that is considered a short term, and anything more than 12 hours is considered a long term. So for long term, you have to follow the full standard. For short term, you can you can get away with placing the drums and cones and get the work area set up, do your work within 12 hours and get leave from that area. But for long term work area, you have to protect the work area. So who on here knows what clear zone is? Basically, that's the main thing that we need to remind. So any work that you do within the clear zone has to be protected. So does everybody know what clear zone is? Does anybody do not know clear zone in attending this presentation? Does everybody know?
Show of hands.
Just show of hands. Or you can see the picture. What clear zone is. So okay.
So let me jump in a little bit here. So basically, think about a construction site as a temporary office of those construction workers. They're going to be there for a year, 2 years, the duration of construction, right? They're going to come in there in the morning or in the night when the construction is going on. And you want to do everything that you can to protect those workers. So if a vehicle runs off of the road, you don't want that vehicle to go and hit a construction worker or even an equipment, because those equipment damages could be substantial, or something is under construction. So that's sort of the idea. Now, I think SHA standards calls for positive barrier protection for a certain speed, high-speed roadways and so forth. But as a prudent designer, you want to make sure that you treat that clear zone area and the work zone as a whole as from that point of view of protecting the workers. So if it is a short term, so it's a sort of thought of the exposure, right? So if it is a short term construction, that means your exposure is relatively less. If it is a long term construction, especially nighttime construction, the exposure factor is way more. And
I'll echo to what Pushkar's saying with that. A roadway like this in construction is more scary than a interstate. And I know that sounds weird to everybody because of speed, but a roadway like this that probably has a prevailing speed of 55 plus miles an hour because there's no obstacles on the roadway. We don't have any real ability to have positive protection on a work zone like this without having an MOT plan to implement it. If you're just out there working on those utility poles, say BG&E or SMETCO or somebody's replacing poles, they have no protection because they're off the road. But when they're looking at it, the reality is a roadway like this could be significantly more dangerous than an interstate where we have the ability to control it more when you're doing the design.
Yeah. All right.
Yeah.
Thank you.
Okay, I think we were at the shoulder taper. Okay, so I believe we discussed pretty much all of it: shoulder taper, shifting taper, and merging taper. And the third work area is the activity area. This is where the actual work is happening. So this activity area includes the buffer space, the workspace, and also the traffic space. The buffer space can be both longitudinal and lateral. You can provide a longitudinal buffer, which is ahead of the work area. lateral buffer, which is adjacent to the travel lane, and between the area between the travel lane and the actual work area. That's the lateral buffer that you can provide more. You can provide, let's say, if the work area is on the shoulder, you can close the adjacent lane and provide a buffer. If it's a multi-lane roadway, that's your lateral buffer. Basically, you're out of the 2 lanes, you're closing 1 additional lane to provide additional buffer. So basically this buffer area is a recovery area for an errant vehicle. It protects the workers. This area should always be empty, as I said earlier. There should not be any vehicles. There should not be any equipments. There should not be any material. Sometimes I've seen TMAs are stored in this area to protect the workers, but somewhere in the standards I've seen that TMA should also not be stored in this area. But I have seen TMAs. Probably
TMA should be after the buffer space. They'll
right.
cheat it all the time, Shaq, but they
Yeah,
are to be after the buffer space.
Exactly. So yeah. So when you show the TMA, we usually don't show the TMA on the plan, but just remember that the TMA should all be outside the buffer area as well. So the buffer length is usually calculated based on the stopping side distance and the perception reaction time. So the table that you see on the right side is basically copied from the SHA standards. So all these values are calculated based on the stopping side distance and the PRT, which is the perception reaction time. I believe AASHTO has 2.5 seconds of perception reaction time. And these numbers, all those come from those formulas. And the second area is the work area. This area where the work take place. The workers, equipment, material, and work vehicles, and everything. Basically, if there is an office or anything, all of this have to be stored within this workspace area. It cannot encroach the buffer area. And the third area is the traffic space. This is the area open for traffic to pass through the work area safely. This area should be completely clear of any equipments, any signs, channelization devices. Channelization devices can be adjacent to the traffic space, but it cannot encroach any width of the travel lane. Or we should not have any other objects within the travel lane, traffic space, which is the travel space. And the last one is the termination area. So basically this termination area includes the buffer and downstream taper. So as I explained earlier, most of the time when I do the design, I assume 100 feet for every lane closed of termination area. You can sometimes I have seen some other designers using total 100 feet termination taper, and doesn't matter how many lanes they close, but my usual practice is 1 lane. If you are closing 1 lane, provide 100 feet termination taper. So and also this the sign, the end roadwork sign. So basically end roadwork sign should be placed at the end of the termination area. So usually it's 500 feet that's placed after the work area. The end roadwork sign, I think that's W20, the G20-2A, I think that's placed at the end of the work area. So maintenance of traffic. Really, do you want to go to the accessibility now?
No, I don't think we will have enough time. I have a meeting too in 5-10 minutes. So
okay. So I can go through these small slides, but we will cover in next presentation. We will cover the category code 100 book that has more details in terms of the design, what needs to be placed, crash cushions, tapers, buffers, channelization devices, the spacing of the channelization devices. As Pushkar mentioned, various types of roadways and various typical applications for the various type of roadways. We will discuss more in detail in the next presentation. But for now, I'm going to discuss some of these milestones, what exactly we present on the plans in terms of design at every milestone. So the basically during the so we usually have 4 steps, right? In the milestones: preliminary, semifinal, final review, and PSNE, which is advertisement 100% plans. So for conceptual MOT plans during preliminary, we only show the shading, preliminary sequence of construction, and the general notes, and also when you do the estimate for the preliminary design, which is the 30%, we only do major quantities estimate. We should not do more than that, because when you do the design, we submit it for review agencies and everybody reviews it. There may be comments that may require completely change of your design. You do not want to go ahead, more than 30% of your design to do the MOT design and later come back with so many revisions because of the review comments. Just present it showing the work area and the shading, preliminary sequence of construction, and some general notes, and just do the major quantities estimate. That should be good enough for preliminary 30% design. And the second one is the semifinal final review design. In this stage, which is 60 to 90% design, we basically do the most of the design. Reviewers and everybody who reviews the plans have already seen the preliminary MOT layouts. They concur with it. If they have any comments, they can provide it to us. We update those, and we update the plans to come up with a 60 to 90% design. During the 60 to 90% design, we show the temporary payment markings, channelization devices, signs, sign sizes, sequence of construction, and also the estimate. When we do the estimate, we do an itemized estimate. Basically, all category 100 items have to be calculated, estimated, and shown in the estimate. And the third one is the PSNE and advertisement. So at that, by the time of PSNE 90% and above, my multiple reviews have been done on the MOT. Everybody concurred with the design. Nobody has any more comments. And at the final review, at the 90% design, pretty much everything is set. Your design is set. Everything is done. All you have to do is address some of the minor comments that are there from the previous design, which is a 60% design or 90% design, and then you're done with the design. And sometimes, and after the advertising, the contractor might have different ideas to do the MOT, but that would be later. The MOT changes will be done by the contractor. He will present it if he has to do any changes to the MOT. At the PSNE, we have to get the TCP approval from the district, and also any specs, any additional specs if you have to do non-standard specs that may be needed. You have to include those at the PSNE design stage. Yeah, this is the same thing that I discussed just now. As Pushkar and Ron mentioned, work restrictions should be taken into account. When we are designing the MOT, basically time of the year, seasonal traffics. If there is a stream that you're working, if there is a bridge, the MOT has to follow the sequence of construction for the bridge. And also the time of the day construction. Basically, if it's a residential or a commercial neighborhood, you cannot do night work. Commercial neighborhood also, there will be a lot of restrictions during the night work. Also design vehicles and design speed. I think we discussed about it for the prevailing speed. And also when you're doing the design, you also need to make sure that any other work is conducted by other municipalities. You have to coordinate with them. If there are any adjacent projects that are in the close vicinity of your project, if they have their own MOT setup, you don't want to have their MOT setup, which is completely different than our work MOT. So basically, that coordination needs to be done before you do any design. As we discussed before, Pedestrian traffic needs to be looked at, pedestrian and as well as bicycles. Access to them needs to be provided at all times. Access to businesses, those needs to be looked into. If you have multiple driveways for business, you can possibly close one driveway, provide access through one single driveway, access egress and entrance and egress from the one driveway. But those have to be discussed earlier. If there is no possibility of shifting the traffic or anything, if we have to close the roadway, the digital plans has to be developed. And use of signals for MOT phases. Sometimes, most of the time, if it's a bridge project or anything, any of these projects that has to be replaced. Sometimes what they do is if it's a single lane operation, and with the less visibility on the other side what's happening, then they put the signal, but portable signals are installed, which can control the traffic. So during MOT, and also don't forget utilities. And those go first during the construction. Basically, the utility sequence needs to be looked at as well when you are doing the design. And additional item that I would like to discuss is, the sequence, as Pushkar mentioned, the sequence has to be determined first, because sometimes, let's say if you have an area where you are excavating a lot of earth, and that earth, if you want to use that earth in the next phase, if you can use that excavated earth material for the next phase, you would want to phase it such a way that you want to utilize that on-site material for the next phase to fill in, rather than hauling it some other place and bringing it back. That would cost additional cost. So your sequence has to be looked at first to make sure that on-site material can be used as and the cost as well. Cost that would reduce the cost instead of hauling it. You can place it in the next phase, leave it on site, use it for the next phase. So the phasing has to be looked into in terms of the construction as well when you do the design. These are some of the plans, maintenance of traffic plans. These are not preliminary level, but I don't think we have a good sample of preliminary plans which do not show any signs. These are some semi-final level, final review level plans. Basically, at the PI level, we only need to show the shading. We don't need to show all these signs and show the work area, sequence of construction, and all the stuff. But the final review stage, we need to semi-final and final review stage, we need to do more. So at the semi-final, as I said, the construction phases are finalized, sequence of construction is detailed, coordinated, and erosion and sediment control as well. The erosion and sediment control usually follows the MOT sequence. The limit of disturbances has established. All these lane dimensions are placed, barrier locations are finalized. Everything is done, completed at final, semi-final, and final review stage. These are some of the final review plans. So maintenance of accessible pedestrian traffic. This section we will cover it in the next presentation. Next presentation, I believe, is after 1 week. We will do that next time. And if you have any questions, you can always get in touch with me, Radit, Pushkar, if you have any questions related to this. Okay. That's about it. If you guys have any questions, we can discuss for a few minutes and then we can close the presentation.
Maybe if there is anybody who wants to revisit some of the items that Shag discussed maybe in detail, we can do that on the next training. You can let us know now, or maybe you can just shoot us an email if you want to get a little bit detail, training.
Okay. All right. Thank you, everyone. Everybody's quiet.
Maybe sleeping, except Anto.
Long meeting, so I guess everyone got busy. All right, thanks, Jack.
All right. Take care, guys.
All right, thank you.